So this is the Geometry Unit 5 Level 1 video. We are going to prepare you for your benchmark that you will be taking. This unit is all about graphs. So we want to talk about some graphs and how to read them, analyze them, and information that we can get from them. So our goals, again, are to be able to analyze different graphs that come in different formats. We also want to be able to answer specific questions about them and to draw some conclusions using the information that is contained in those graphs. Most of these graphs you've probably seen before. We are just going to talk about what they look like, some information that they contain, and how you can analyze them. So here I have a bar graph. A bar graph clearly has bars. Makes sense, right? So each bar that's on this bar graph represents the quantity of things that are in that category. In this case, we are talking about nicest fruits. I know that because that's what the title tells me. So each of those bars represents a fruit. The axes describe the different measurements. So I can see that we're talking about apples, oranges, bananas, kiwis, blueberries, and some sour grapes apparently. I can also see on the side there that the number of people that prefer this fruit is listed. Which one is the nicest fruit? Clearly, blueberry wins out. I like blueberries myself, so I get it. It is far higher than the other ones, coming in at 40 people that chose blueberry. So that's how I know, because there are 40 people. The next highest is apple with 35, and so on down the line, all the way to those grapes that nobody seems to care for. Which brings me to the next question. How many times nicer are blueberries than grapes? Well, if I know that blueberries are at 40 and grapes are only at 5, that means that blueberries are 8 times nicer. Would you agree with that statement? I'm not sure I would, but I do like blueberries much more than grapes, and they are very healthy for you. So maybe that's why 40 people chose them over the 5 people who chose grapes. All we did to get that number was divide 40 by 5, which is 8, meaning that blueberries are 8 times nicer. This is kind of a silly little graph, but it illustrates nicely how we read a bar graph and what we can do with the information contained in it, okay? Next up is a line graph. This is a line. We are graphing different data points, and they are connected by a line to show a trend. Almost always that trend is over time. You can see here, if I look along my bottom axis, I'm talking about years, from 2017 to 2022. Multiple lines are on this graph because it's showing me different things. So if I'm going to look at this key at the bottom, I can see that I have a line for bears, I have a line for dolphins, and I have a line for whales. And then those trends are showing me here. Now, why do I have 2021 and 2022? Those would be extrapolations, or what researchers believe would be the trend based on what they are seeing in the past several years. So those are not actual data points. Be really careful when you're looking at graphs. Notice what they're talking about, because we haven't gotten to 2022 yet. We don't know how many bears there are actually going to be. However, based on the data that the researchers are collecting, they are making some predictions, I guess. I don't want to say guesses. I want to say predictions about how many bears, how many dolphins, how many whales there will be in 2022. Now, that is, of course, assuming that nothing changes. Maybe we make a big effort to clean up the oceans and the whales stop dying off. Who knows? I hope that happens. But again, pay attention to the key on the graph, because that tells you a lot about what's going on in the situation that the graph is talking about. Now, the question here is, which animal population is growing? Clearly, the bears are growing, because we can see that that line is going up. Which population is shrinking? That would be both the dolphins and the whales. Okay, so dolphins and whales are shrinking. Which one is shrinking more or faster? That orange line that's dolphins really seems to drop. The whale line kind of seems pretty steady, actually. So I don't know if I would necessarily say that they're shrinking. Maybe we cross that off, and maybe we say that the whales are just staying constant. Yeah, they fluctuate, but they're kind of pretty constant over time. okay? And then the next question is, do you think one has anything to do with the other? Do you think that the rising bear population might be causing the dropping dolphin population? I don't know. I guess it depends on the kind of bear we're talking about. And they don't tell us, do they? But if it were polar bears that live near water, I might say maybe. Polar bears can swim, and I know that they like, sea lions and other fish in the sea. So maybe they are going after the dolphins. Maybe it's completely unrelated. Maybe this has to do with pollution in the oceans and dolphins who tend to live closer to the shoreline interact more with that pollution, and it's causing their population to die off. Whereas whales that are out sort of in the deep ocean aren't impacted as much by pollution, and bears that live in the forest are actually not impacted by sea pollution at all or ocean pollution. So it really could be anything. We would probably need a little bit more information to answer this second question about whether one population has anything to do with the other. We're not given that information, so we can maybe make a couple guesses, but we can't really know for sure if one is impacting the other, okay? So a line graph, again, shows trends. Almost always it's over time. And it shows how, in this case, the population is changing. It could be showing how sales are increasing or decreasing, or marketing is impacting your bottom line, or whatever. Line graphs contain a lot of information. The axes and the key are really important to help you know what it's talking about. The next graph that I want to talk about are circle graphs. They're clearly in the shape of a circle. I know these are all named just so great. You know exactly what kind of graph it is because it tells you. So this circle graph is cut into pieces, and it kind of looks like a pie, okay? Each piece of the pie represents a different category, and it can be about whatever topic you're talking about. So when you are looking at a circle graph, the title is very important. It tells you what the graph is about, okay? So this graph that we have here is about favorite type of movie. So I know that I'm looking at different movie genres, and then each category is a different percentage of the whole group that was polled or asked these questions. Remember that a whole is always 100%. So all of the percents in a circle graph should add up to be 100. If they don't, something went horribly awry, okay? So your total should always be 100. In fact, if I add these, say 20, 40, 65, 95, 100. They all add up to be 100, okay? Now, the question here is which type of movie is most popular? So I'm just going to pick the one that has the highest percentage. That would be romance at 30%. Coming in a close second is action. Sci-fi and comedy are tied, and then apparently nobody really likes drama very much, okay? How many people were asked? How do I know that? I have percentages here, but that doesn't mean that 100 people were asked. You can see next to the percentage, I have a number. That is the number of people that chose that category in this poll or survey, okay? So if I add all of those up, 5 plus 4 is 9, plus 4 is 13, plus 1 is 14, plus 6 is 20. I know that 20 people were given this survey and chose their favorite type of movie. Now, the one thing keep in mind, occasionally you'll get a circle graph that has a category of other. There's always got to be that one who refuses to pick chocolate, vanilla, or strawberry and has to have mint chocolate chip or whatever. Okay, you always have that one person or two people who want to be in the other category. Again, pay attention to the title because that gives you at least a clue of what the other could be. Okay, and that's always really important when you're looking at these circle graphs. So that's our third type of graph. Our last type of graph we want to talk about is called a scatter plot. It is a plot of data points that are scattered across a graph. Notice they are not connected because they are not a trend over time. We're not talking about the same thing, okay? So on that line graph, we were talking about the dolphin population in 2017 and 2018 and 2019. That's not what we're talking about here. When you look at a scatter plot, you are talking about individual data points for different people or situations. Each point is its own piece of information, okay? And when you are graphing these, you have some type of correlation. A correlation is when the dots seem to form a line. And you can have different types of correlation, okay? You can have a high correlation where they are almost exactly in a line that's very clear. A medium correlation would be when many of the points fit the line, but not all of them. Low correlation, you can kind of see that there's a line, maybe through the middle, but the points are kind of all over on both sides. And then no correlation is when it doesn't look like it could be a line at all, okay? So I've got a couple different scatter plots here. The first one is a scatter plot of weight versus height. Again, the titles of these things are very, very important. So each point is a person. So we have a person who is 62 inches tall and it would appear to be about 115 pounds. I've got another person who's 63 inches tall and is about probably 125 pounds. I have another person who's 68 inches tall, also seems to be about 125, 24 pounds, okay? So each of these data points is a different person's height and weight. Now look at this person here. This person is about 68 inches tall and weighs 200 pounds. That would be an outlier. That doesn't seem to really fit the rest of the data, okay? Now, when I look at this, the question is, what is the correlation? I can see that if I were to graph this, I could get probably a line down the middle. However, most of those data points are not going to be on the line. So I would say that this has a low correlation. Okay? Because I can see a linear trend, but most of the points don't actually fall onto that line through the middle, okay? Looking at this second one, I'm talking about sales versus temperature. Now, why would I care about a sale amount in a temperature? What if I told you that this is an ice cream store? And they're tracking the amount of sales they have for what temperature it is outside. That kind of makes sense now, right? If I look at this graph, I can very clearly see that this is very linear. As the temperature goes up, so does the amount of sales. Kind of makes sense, right? The hotter it is out, the more we want to get ice cream. I would say that this has a very high correlation between ice cream sales and outside temperature, which makes sense in real life, right? Okay. So a scatter plot is kind of an interesting piece. It shows you a lot of different data for individual points, and then you have to see what the correlation is. Do they correlate to each other? Sometimes we get one where the two things absolutely do not correlate. Sometimes we get one where there's a very high correlation, and sometimes there's pieces in the middle, okay? So it just kind of depends. If I were to, for example, make a graph of how many homework assignments you did and your test grade, I would assume that most people who did all of their assignments had a higher test grade. I think we could probably see a correlation between the amount of homework you're doing or assignments you're doing and how high your test grade is. Now, there's going to be some outliers to that, okay? If I took a survey about age versus favorite ice cream flavor, probably not going to be a correlation there, okay? Because how old you are doesn't really determine what ice cream flavor you like. Everybody likes something different. So you're not going to see a correlation if you were to graph that. That is just something that would have no correlation because there's no relationship between the two. So when we look at scatter plots, we're looking for a relationship between the two pieces that tell us some information. I hope this makes sense. I hope you understand the four different types of graphs. You're going to see these on your benchmark, and you're going to have to pull some information out and explain, answer some questions, as well as put things in order from smallest to biggest, and just basically understand what the graph is telling you, okay? So make sure you do that assignment, your level 1 assignment, answer those questions, and you should be all set for your benchmark.